Hello friends, this is my first video regarding video to block generator. So here I am using some LLM pipelines using LangChain and LangGraph to understand its differences. As you can see nowadays, in place of LangChain in production purposes, generally we use as LangGraph because it's more flexible to complex workflow. So I'm basically trying to convey the difference between these two things using my workflow. In next video, we will discuss the entire project using my Streamlit app, how I build that using LangGraph. Okay, so let's go to the workflow. So here I upload the video. As you can see in the first step, we upload the video, then we extract the audio, then we generate the transcription using that Whisper model, using that audio file, and using LM, we use the transcription and generate the summary, and then again we use the LM file LM for you use that summary to generate the block, and after that we get the block. Okay, so these are the imports which I have done. I'm using 3.5 mini instruct model for my LM as LM because it's smaller and gives me good result, decent result for my current workflow. And I'm using for transcript generation, I'm using OpenAI Whisper and using PyDub file for conversion audio to video to audio. Okay, so these are my audio extract audio function. I'm passing key value pairs as a video path, so it basically convert into the temporary WAV file, which is mono-channel audio because generally Whisper model accept the mono-channel audio, not the stereo. So yeah, but there's some discrepancy. That's why we use this audio segment and this thing to make it a 16-bit mono 16-bit WAV format. Make the audio stabilized, so it can be easily transcripted using Whisper model. So yeah, I'm saving it in that dictionary format as a temporary file, whatever the changes I've done. Now I'm calling the transcribe function where I'm calling the Whisper model. Here I'm passing the state, checks whether any error came in the state dictionary or not. If not came, it read the audio file and then load the model and you process the audio file for transcript generation and return me in the dictionary format in the form of text. Okay. Otherwise it will give me error. Now summarize transcript generation, it will all again check the state and then check if any error came, it will return the dictionary. Otherwise, it will process the state dictionary and text file uh, with the empty key and then strip it. If any error comes, then it will give me that its string is empty completely. Otherwise, it will go through the my prompt where I describe the prompt. Uh, so like summarize the transcript bill for a blog post. So yeah, here I'm passing my transcript and then call the models and then it will generate the summary and store the result. This is my last function, which is for block generation, where I describe check the state dictionary. If state summary does not exist, then it will not work. It will give error. Then if it's not empty, then it will generate me like I've described the prompt, like your blog later, like something like that, describe in compelling titles, like that thing. And yeah, I'm passing my 5.3 mini model. And also I've included the summary because through summary I want to generate the blog. Okay. So yeah, here I trim it after title because title and unnecessary thing I don't want. After title I want because it contains the actual blog after that. So yeah, here it's storing in the dictionary format. Next thing, it's block state. Block state function I am describing as a type dictionary. This is for generally validation purposes, but here I don't use that PyDict function. Here I am using simple like type dict function, not pydantic. You can use pydantic for data validation. For simplicity purpose, I use block state. Here I am describing my all the file, whether the video path should be in strict, audio should be in strict, text should be in strict, summary blog post should be in string, error it should be optional. If it occurs, then it will save it. Here is the major difference came. So state graph where you start your initial describing your initial node. So initial, you can say starting point where you describe all the variables in the graph using this function, state graph function, where you're passing this class where to initialize all the values. Then we add the nodes where where we describe all the nodes like extract, graph, transcribe, summarize, and log. So here for treating as a chain component to a function, we generally cover it with the runnables, lambda runnables, because these are not a chains, or we can say not a chain component. So for converting the function into chain components, we generally call it runnable lambdas for customizing our function to chain components. And I'm wrapping it with a node value because I'm working in LangGraph. So I'm converting that runnables into a graph node. Here I'm describing my entry point of a graph, extract audio. Then I'm adding the relationship, how the graph workflow will work. So here I describe extract audio to go to transcribe, transcribe to summary, summary to generate block. And then here I describe the end so that graph will end its working. Here I describe the, here I basically call my graph using compile, and it will generate my entire workflow, graph workflow. Okay. Now here is the main function games. So here I describe my video file. As you know, this graph pipeline I already described. So just have to pass the video path and it automatically work and give me the output. Here it will check if any error comes in that output or not. If no, then it will go through this flow where if check if title is present, generate title is present. That's why it will trim the title and give me the remaining text as a block. So yeah, there I display my blog. This is my final blog. You can check. This is my result. So this is the result generated by LangChain, LangGraph. Okay. Now let's see what are the difference came in LangChain. LangChain it's quite like easier compared to LangGraph. Here all things remain the same. Here we directly describe our chain component using the runnable sequence, because runnable sequence work is to arrange the chaining components into sequential format. So just you have to call all the runnable chain component lambda components in a sequential format using the pipe. Here I am describing extract video, audio, transcribe using Whisper, and summarize, transcript, and this thing. So using pipe functionality, it will automatically convert into sequential runnable sequential chains. You don't have to do that much like creating edges and creating graph, initializing graph and compiling it. It's very simple. So yeah, remaining things should be same, that you invoke the pipeline and call the video path, and then it will generate the output. If no errors came, then it will strap it and give you output. The reason of showing these two things is because to give an understanding how what are the differences between LangChain and LangGraph. There's minute changes, but of course, if you go to the complex workflow, then it differs a lot. But in scaling purposes, generally in big companies, you generally uses LangGraph. Nowadays, LangChain will not work on complex workflow. The authors also said that you can check on their documentations. But yeah, companies generally trying to shift with the LangGraph. That's why I showed you with two what are the differences. Okay, that's all in this video. In next video, I will describe that complete workflow in a form of Streamlit app, where generally I uses the LangGraph for. Hello friends, this is the next video where I'm trying to convert the LangGraph workflow to a simple Streamlit app. So here I'm not using the LangGraph or anything else, just converting the entire workflow and doing some stripping and this thing to make the app work. Okay. Just to make it simple, I don't use LangGraph workflow in this program. Okay. So let's go to my folder. So I have created two files. This is streamlit app.py, which contains the main file. Pipeline, generally I integrate all the functions for conversion of my video to blog, where I try to like convert audio to like video to audio conversion, then audio to transcript generation using LLM. I generate summary and then try to convert a blog and return the blog post. This is my first pipeline.py function. Second in streamlit app.py. Here I am calling streamlit. Then I am importing my process video log function. This is describing the title. Here I am showing the format it accepts. That is .mp4. Here it processing it, and then it will display the blob in a subheader. Yeah. So this is my basic project. Let's run it for and let's run it for better understanding. So let's go to command prompt and we type not Streamlit run stream. So it activated. Now you can see it. It's take a while for loading. Okay. Now I am checking this thing for processing. Okay. Now it take a while. Uh, let's see the video which I'm using. This is the LangChain video.
Now, stop me if you've heard this one before, but there are a lot of large language models available today. Has a standard interface for all models. So pick an LLM of your functions for to include inputs like agent modules can use an LLM to. And if you have any,
so this is 8-minute long video. It will take a while doing processing. Okay. Yeah, it's still processing. So yeah, I will get back to you later when you process to show the result. Hello friends. So this is the result generated by my Streamlit app. As you can see, this is the title, introduction. We will describe the LangChain or the LLM technologies and how the LangChain integrate on that LLM in this thing. Of course, it will not generate complete because we restricted our length to 512. So yeah, this is our complete tutorial regarding video to block generator. Okay, thanks for watching.